Adjacent angles. First, let's define it, then let's talk about it. So here's what adjacent angles are. Holy moly! Two angles that lie in the same plane and have a common vertex and a common side, but no common interior points. So you can pause the video and write that down for yourself. What does it mean? Adjacent angles. First, two angles. It could be more. Well, no, it's just two. Sorry, two angles. So I'm going to highlight one of them. You see? Angle 1 right there that I have highlighted. Okay, if you want to highlight along, highlight along. You also see angle 2 right here. Those are adjacent angles, and let's realize why. First of all, they're in the same plane. We'll always assume that unless they show us three-dimensional pictures, but we're in the same plane, so check, we got that done. Do they have a common vertex? Isn't that point the vertex of both of them? Do they have a common side? Did I highlight one of those rays? See, it's important to know what sides of an angle are now. Isn't that the rays that make up that? Did I highlight one of those rays, both blue, well, I didn't use blue, both green and red at the same time? Did I do that? That'd be this one right here. Isn't that common to both of them? Then this is the tricky part. There's no common interior points, meaning if I shaded the green one in, like isn't this all the interior, correct, of the green one? And all the red one, if I shade that in, did I ever highlight red on top of green in those interiors? Yes or no? I did not. Okay? Now let's go to an example to where they're not adjacent angles. You can see over here there's non-examples. Angle 3, right? And the other angle they talk about is angle ABC. Whoa, isn't this angle ABC, right? Now first let's go through it. According to the rule, do they have a common vertex? I believe they both have B for a vertex, right? Do they have a common ray? Do they have a common ray? Didn't I highlight ray BC, both red and green at the same time, correct? Now, do they have no common interior points? Well, let's see. Let me highlight the red one first. Isn't this all the interior of the red dude right there? Cool? Now let me, all the green one. Isn't that the entire green one? Did I ever have some interior of the red and the interior of the green on top of each other? These are not adjacent. Isn't that red angle completely on the inside of that green angle? Okay? Now let's break it into real world things about like adjacent classrooms. My classroom and Mrs. Colwell's classroom, which is right next door, they are adjacent because don't they share a wall in common, right? They are totally touching each other. Cool? But my classroom and Mr. Peterson's classroom is where I was last year, which is across the hall. Is there any wall that's common to either one of those? They're non-adjacent. They're not touching in the first place. Now, what about my classroom and this closet? The closet is sharing this wall, but isn't this closet inside of this room in the first place? They are also not adjacent. They have to be two totally separate rooms that can only share a wall in common. This is like two totally separate angles, but isn't this red angle inside of the green angle? It just doesn't work. So in our own words, adjacent means they are touching, but only at like a common ray kind of where they're not inside each other. So angle 1, boo boo. Angle 2, red. Boo boo. You see how if you shaded them both in, there would not be any interior common points, but they do share one. This guy, angle 3, boo boo. And angle ABC, boo boo. Do they even touch each other in the first place? They are non-adjacent angles. So adjacent, for our own words, means they're touching, okay? But they can't be inside each other. Sound all right? All right, so let's do this. Let's draw acute angle 4 and obtuse angle 5 as adjacent angles. Sound okay? So one thing at a time. First of all, should they be touching each other? They better be, right? Let's start with acute angle 4. So how much should it measure? Less than 90. Can you just kind of guesstimate? I don't need a protractor necessarily. Can you just kind of guesstimate? Wouldn't this be 90 degrees straight up and down? What if I did this? Would that be acute? For sure. We could put a protractor on it and it would be acute then, correct? So just do that, and it needs to have a 4 on the inside of it. Sound okie dokie? Now, angle 5 is supposed to be obtuse, so it doesn't have to be bigger than 90. but it's also got to be adjacent to this, so don't we have to share one of these guys in common? Which one do you want to share, that red one or this blue one? Because it doesn't matter. Which one do you want to share? Blue one would probably be much easier because it kind of points to the right. So let's share with that blue one, and we'll just kind of draw with our straight edge, if I can find my straight edge, off of it. I just need to look at it, maybe turn my paper a little bit, and realize this would be where it is right, nice and straight up and down. If you turn your paper, I need it to be obtuse right there. So angle 5. If you want to use your protractor and measure, use your protractor and measure. But there's angle 4, it's acute. There's angle 5, it's obtuse, and those two are adjacent in the first place. Feel okay with that? Next one, draw angle 6, excuse me, angle 6 and angle 7 as non-adjacent angles. Give that a shot with PAL. Pause the video, get that done. That is by far the easiest way to draw non-adjacent angles. Were they ever touching in the first place? Don't make it any more complicated than it has to be. Non-adjacent, sure, you could try to draw stuff like this guy or this dude inside another one, but that's complicated in my opinion. Non-adjacent, I don't want them to touch each other. Cool? Let's roll on. Complementary angles. You heard of that before? Complementary, supplementary, you heard of those two words? What does complementary mean to you? Yes. Complementary, the two angles whose sum is 90 degrees. Two angles. Notice how I put that in all capital letters, because that was like important. It's only two angles whose sum is 90 degrees. So let's draw a pair of adjacent, so they got to be touching each other, right? Complementary angles 1 and 2. Well, let's think about the whole goal. If they're complementary, when we add them together, what will it look like? 90 degrees. But they got to be touching each other, so when we put them together, won't it look like a right angle? So let's start with a right angle. Let's do that. Let's start with a right angle. Sound okay? And then I need, that's a horrible looking right angle, sorry. Do we need a box? That's a good question. Not necessarily, because we're going to put more info in it. If you have a box, it's not wrong. Like, don't get me wrong, okay? But what I wanted to show you next was, aren't we going to put more info in this picture? So I need to split this into two angles, but they're supposed to be touching each other. So that means we've got some sort of ray in here. Does it have to bisect it? Do they have to be 45 degrees and 45 degrees? They didn't tell us it was bisecting, right? Could it be 30 degrees and 60 degrees? Could it be 50 degrees and 40 degrees, right? So does that thing have to go smack dab right down the middle of it? So let's not make it down the middle. Let's put it like right there. Wherever, you know. But one of them's angle 1, the other one's angle 2. Are we down with that? Yes, no, maybe? Now, how do I know that they're complementary? I got to make up some angle measures. I didn't even measure it, right? Didn't even use my protractor. If you want to, you can. But make up something for this angle. What do you want it to be? 30 degrees. Cool? Now we have no choice of what the other one has to be. If this is 30 degrees, what does that one have to be to make them complementary? 60 degrees. And do you see how now you don't necessarily need the right angle box, because we can see that it adds up to 90 degrees in that situation? Cool? Let's draw a pair of non-adjacent complementary angles, angle 3 and angle 4. Non-adjacent, let's make it easy. What does that mean to us, non-adjacent? Not touching. So let's do angle 3 first. Use a straight edge, of course. There's angle 3. And let's just do our best guesstimate. The only time they really want us to use a protractor is when they tell us to use a protractor to measure something or anything. If they say, please make a 50-degree angle, then you use that. So what do you want that to be? About how much? What does that look like to you? 40 degrees sounds great. Okay? Got to have a 3 in there. Now we know our other one can't touch it, right? It's like MC Hammer. Woo, that's old. And it's going to be angle 4. And how much should it measure if they're complements of each other? 50 degrees. 50 degrees. So those non-adjacent complementary angles. Feeling pretty good about those concepts. So if we know what complementary means, the word complement is very, very similar to it. The complement to it. Just like what I kind of was doing right here, if I cover this up for a second and I said, hey, we drew a 40-degree angle and we need another angle to be like complementary, and this was 40, what was the other one? 50. That's called its complement, the other angle that makes it add up to 90. So in the problems below, an angle measure is given. Find its complement. If they give me a 30-degree angle, what's the complement to that going to be? This is what you would still need to make it add up to 90, right? That's the complement to that. How about a 21-degree angle? So wouldn't I need to get 60 more to turn that into an 8, and then a 9 right there to turn that into a 10, 69 degrees? How did we get that real quick? Let's say I didn't have the greatest mental skills. What could you do? Like, how did we get 60, really? 90 minus 30, right? How did I get 69? How could I get that? 90 minus 21. So 76 degrees. Don't we need 90 minus 76, which is how much? Is it 24, or is it 14, or is it 4, or what is it? Pretty sure that it's 14. With me? Get 8 done for me. What's the complement to an 89-degree angle? What is it? 1 degree. The complement to a 110-degree angle. What does complementary mean again? They got to add up to equal 90 degrees. So to go from 110 to 90, I would need negative 20 degrees. Can that happen? Can an angle have a negative measure? So what's the complement to a 110-degree angle? There is none. It doesn't have a complement. Not every angle in the world has a complement. It's more than 90 in the first place. Sound cool? And now here's what I was trying to set us up for. This will save our lives on Thursday, if we can figure this answer out. Let's go through the process one more time. How did we get 60 degrees? We did what? 90 minus what was given to us? 30. Wasn't this answer 90 minus 21? Wasn't this answer 90 minus 76? This answer was 90 minus 89, right? This answer couldn't be done. If I give you an x degree angle, what is the complement to it? This one was 90 minus 30. This one was 90 minus 21. This one was 90 minus 76. This one is 90 minus 89. So any angle that I give you, how do you find its complement? 90 minus x as a quantity, degrees. It's not x minus 90. It's 90 minus x, right? Just put in for whatever you want x to be. Now, sometimes it can't happen because that's bigger than 90. But in general terms, the complement to any angle is 90 minus that angle measure. Sound okay? That's complementary. 2 angles. Supplementary. If complementary is the sum of 2 angles equaling 90 degrees, do you have a wild guess of what supplementary would mean? It'll still be 2 angles that add together, but they won't equal 90. How much will they equal? 180 degrees. 2 angles whose sum is 180 degrees. The problem that we have now is we get messed up with complementary, supplementary, and 180 and 90. It's like, oh my goodness, I can't remember which one goes with which. Here's a little secret that I've learned over my years. If I put the 2 numbers in numerical order, doesn't 90 come first before 180 if I put them in numerical order? Cool? If I put the 2 words complementary and supplementary in alphabetical order, doesn't C come before S in alphabetical order? They match up. Complementary goes with 90. Supplementary goes with 180. Complementary comes before supplementary in alphabetical order. 90 comes before 180 in numerical order. So I just realized, oh, well, complementary and 90 come first. They go together. Supplementary and 180 go second. They go together. Does that kind of make sense to you? So draw a pair of non-adjacent supplementary angles, 8 and 9. Show me. Should they touch or should they not touch? Not touch. Let's start with angle 8. Draw whatever you want it to be. Angle 8. Right there. Got her drawn. Now let's guesstimate how much it is based off your drawing. To me, my angle looked like 45 degrees, so I put 45 degrees. Now I need to think of the other angle that makes it add up to 180, which would be called its supplement, right? If these are supplementary angles, supplement. What's the supplement to a 45-degree angle? You can use a calculator. How would you figure it out? 180 minus 45. What do you get? Anybody? 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 135 degrees is what mine should be. What kind of angle is that? Acute or obtuse or right? Someone make it look obtuse. How come I didn't make them touch? Non-adjacent. So based off whatever your numbers were, make sure that those two angles, they're not touching each other, and they add together to equal 180 degrees. Excuse me. And how many angles did I even draw in the first place? 2. Now I want to use a little bit of thinking. Okay? Next thing they want us to do is draw 2 adjacent supplementary angles. Right? Adjacent supplementary angles. Should they be touching each other? And they add together to be how much? 180. What happens when angles will touch each other and add together to be 180? Just like back here, way back yonder, didn't these touch each other and they added together to be 90? It formed a right angle, correct? If you have two angles that add together to be 180, but they got to touch each other, a shape will appear. Anybody know what shape measures 180 degrees? Not necessarily. So we didn't know, so let's try one. Let's draw angle 6. Let's make this dude point this way. And let's just go, let's kind of make it about, real easy number to deal with. How about 30 degrees? Would that be okay? Let's make it roughly about 30 degrees and put a 6 inside of there. But I need a supplement. And they got to be touching, right? They got to be touching. So what is the supplement to a 30-degree angle? First of all, how much do I need? 150, right? But it's got to be touching it, so doesn't it have to basically start from this ray right here? So we need to start from there. And it's got to be 150 degrees. And 150 plus 30 is 180. And something will appear that makes 180 degrees. Here's what it'll look like when we're all said and done. It'll all look like this when we're said and done. This will be the 150-degree angle right there, angle 7. See this shape right here? What is that? That's a line, baby. 180 degrees is a line right there. 180 degrees. So when we draw adjacent supplementary angles, they will always form a line. Does that kind of make sense? Because they have to add together to be 180, and they have to be touching each other, so they will form a line every single time. Cool? Why don't you find the supplement for me right here, since we kind of already know how to do that. You and Pal get all of those done. 180 minus x. Should it be in parentheses? Yes. Where does the degree symbol go? Out there. 180 minus x. That's the general case. Did we have any situations where we had no supplements? No. Because they're giving you an angle measure, which already measures 180 or less, right? It will always have a supplement, but angles do not necessarily always have a complement. So far, we've talked about adjacent angles, complementary angles, and supplementary angles. How are we feeling about those? Good. Now let's search your brain. A linear pair. It's in the name. Do you know what pair means? 2. Do you know what linear means? Forms a line, right? Boom. A pair of adjacent angles. A pair of adjacent angles with non-common sides that are opposite rays. Sorry, I had a freak out there for a second. A pair of adjacent angles with non-common sides that are opposite rays. So let's see it in a picture. Here's green angle right here, angle 1. Here's red angle right here. Do you see that this is the common side? Isn't that highlighted both green and red at the same time? But I don't care about the common side. I care about the non-common sides, right? That would be this dude, I'll use blue, this dude right here, and this dude right there. Or those are the ones that was singly highlighted green and singly highlighted red. Together, they form what's called opposite rays, which is known as a line. Two angles that touch each other and form a line is what a linear pair is. Sound okay? Two angles that touch each other and form a line. That's what it is in our own words. Groovy, 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 groovy. So if you see here why these are not a linear pair, angle ADB in blue and angle ADC, those are two angles, and they sure do touch each other. Isn't this the common ray between them? But you see the non-common rays, do they form a line? No, that's not a linear pair. These are just plain old adjacent angles. Cool? So to be a linear pair, they must be adjacent angles that form a line in the first place. Okay? What's so great about it? Well, let's draw angle ABC and angle CBD as a linear pair. Why don't we start real easy? Do we know what shape will appear when we're all said and done? Why don't we draw a line to start with? Green line, arrows, diddly-diddly-doo. Nice and neat. Start with a line. Plus U. If you sneeze while watching the video at that exact same time, that would be amazing. So, there's my line. To draw a linear pair, the next thing you do is you just take a ray and you go boot straight off of it right there. Aren't those two angles now that I have in the picture? And they touch each other and they form a line? Let's put the details in there. First one's angle ABC. What is the vertex? Doesn't that have to go right here? Correct? A goes on one of these guys, and C goes on the other. And honestly, it does make a difference where the A and the C go now. It does make a difference because what was the other dude's name? It's angle CBD. We need to use the C and the B to help us form the other angle. Isn't C on this ray already? B is the vertex still, and shouldn't D go right there? You with me on that? Angle ABC and angle CBD, they form a linear pair. Groovy? Don't even need to put any numbers in the picture because they form a line, right? We always can assume that lines are straight and they measure 180 degrees, so boom, done. That's a linear pair, no doubt about it. Now let's do number 20. In the drawing from 19, if the measure of angle ABC is 100 degrees, that in your picture, if they give you information and you have a picture, let's put it in the picture. So didn't they say measure of angle ABC is 100 degrees? Put that in your picture. That goes right here, correct? What is the measure of angle CBD? Anybody know what it has to measure? 80 degrees. Why? Because they're supplementary, correct? They got to add up to be 180 degrees. So if this is 100, that's 80 degrees. If two angles form a linear pair, then they are supplementary. If two angles form a linear pair, then they are supplementary. That is the linear pair theorem, my friend. What we need to realize is how easy these problems actually are. To do any proof, they must give you some information. Do you see here, all of this is given information right there. So what did they tell us? I don't even have a picture, right? But they say angle 1 and angle 2 form a linear pair. Boom! I already know they're a linear pair. How come? They told me so. Cool, they gave me that information. They also told me that the measure of angle 1 is 45 degrees. So if angle 1 and angle 2 form a linear pair, and you know that angle 1 is 45 degrees, can we figure out what the measure of angle 2 is? What would the measure of angle 2 be? 135 degrees is correct. And the question is, why? And we don't write a sentence. We don't do any of that. We use either a definition, a postulate, or a previously proven theorem for a justification. Why did we know that? Well, isn't that exactly what this says? That if you have a linear pair, then they're supplementary. Do you know what supplementary means? It means that they have to add up to be how much? 180. So, did we have a linear pair? Did we realize that they should be supplementary? That is the linear pair theorem. That says so. We knew, and you can abbreviate theorem THM. The linear pair theorem says, hey man, in any situation, if you've got a linear pair, those two angles have to be supplementary. Fact, Jack. It's been proven. You just kind of proved it right there to me generically. Cool? Let's try it again. They give me some information. Angle 6 and angle 7 form a linear pair. They also tell me the measure of angle 7 is 113 degrees. Can we figure out what the measure of angle 6 is? Of course you can use a calculator, but can you figure out what the measure of angle 6 is? What should it be? 67 degrees. How did you get that? Didn't you take 180 minus 113? Right? But we're not going to say why, because they're supposed to add together to be 180. We don't do that. Right? We use either a definition, a postulate, or a previously proven theorem. Do we have any previously proven theorem that says linear pairs are supposed to add up to be 180? Linear pair theorem says so. It's such a simple game, right, if you know how the rules work. That's my job, teach you the rules. You don't just make stuff up. You don't put what you want for a reason. Either a definition, like, oh, I don't know, like the definition of bisector. Don't we know what bisector means and stuff like that? Or theorems that we know about, or any kind of assumptions like postulates that we all believe are true. Let's go to the next one. Vertical angles. I already defined it for you because it's such a difficult definition. I could care less about that definition if you remembering what it is. What I just want to talk about is two non-adjacent angles formed by intersecting lines. What's the most important word in there? Probably lines, since it's in capital. You know, that's kind of how I read things. But here it is. Check it out. You see two lines that intersect and form an X in this situation. That's how I know you're looking for vertical angles. They form an X. Two lines. Look at this. Are these two lines that intersect at an X? Is that a line? Not a line. It's not straight. That's nice and straight, correct? And this is nice and straight. Cool? So here's what I want to do. Let's make something up. Let's put 100 degrees in here. Put that in there. 100 degrees. Just making that up. Now, let's pretend we don't see this. Let me give me a little bit better spot here. Pretend we don't see that stuff over there. Cool? See these two, angle 1 and angle 4? Anybody know what kind of angles angle 1 and angle 4 are? That's a good question. When I ask you what kind of angles they are, we need to throw these out. No acute, no right, no obtuse, none of that stuff. Okay? Not even complementary, not even supplementary. So far, you have only learned two kinds of angles, adjacent and linear pair, and I don't even care about adjacent. My question is, are angle 1 and angle 4 a linear pair? Cool. Anybody know what the measure of angle 4 should be? 80 degrees. Anybody got a justification of why that's got to be 80 degrees? Anybody know? Linear pair theorem, right? Don't make anything up. It's just 3 words. Linear pair theorem says so. Cool. Uh-oh. Let's move this. Maybe. Check out angles 2 and angle 4. Does anybody know what kind of angles those are? 2 and 4. Aren't they a linear pair also? Can we figure out what the measure of angle 2 would be? How much should that be? Why? Linear pair theorem, right? That's all that this class is. You're going to do something, and I'm going to ask you why. That's all that this class is. You better have a reason for it. Didn't we have a reason why that's 100 degrees? Linear pair theorem says so. Okay, now let's move. Look at angles 2 and angles 3 only. What kind of angles are angles 2 and angles 3? Are they a linear pair? Right? Does anybody know what the measure of angle 3 should be? Oh, how come? Linear pair theorem says so. 80 degrees. And now, I'm going to keep moving this. Look at 1 and 3. We haven't looked at those yet. Are they a linear pair? Are they already supplementary? It's amazing. We got all these crazy different pairs of linear pairs in this system, in this situation, in this picture. Well, here's vertical angles. In our own words, this is important for us to realize. There are two angles that are like across from each other in the X. Look at these guys. Are they like right across from each other in the X? Those are what we call vertical angles. Angle 1 and angle 2 are vertical angles. And now we got to understand that vertical, you have been taught, means straight up and down, and horizontal means left and right. There's no such thing as horizontal angles. These guys, are they right across from each other in the X? Those are also vertical angles. Even though they're going vertically, right, they're considered what's called vertical angles. Two angles that are across from each other in an X. Okay? So let's draw this picture. Draw one picture where angle 6 and angle 8 are vertical angles, and angle 7 and angle 9 are vertical angles. Let's see if we can do that. And here's the easy way the picture should look like in the first place. Like an X. Two straight lines that form an X. So, boom, one line, two lines. Got to make an X. They're supposed to be vertical angles. Cool. Give me a 6 and an 8 in the picture to where they are vertical angles. Just do that and stop. Angle 6 and angle 8 are vertical angles. When you do this on your homework, make sure you're using straight edges all the time also. Okay? So, if I put a 6 here, right, which I didn't have to, but I did, I want you to tell me, multiple choice, A, B, or C, where does the 8 go for them to be vertical angles, at A, B, or C? It's got to be at B, right across from each other. These are next to each other in the X, right? These are a linear pair. These are a linear pair. These are right across from. Would you believe angle 6 and angle this are not a linear pair? Cool? So that's angle 8 right there. Then put you a 7 and a 9 in the picture to where they're also a linear pair. 7 here, 9 here. Is that pretty cool? What do you think? And we've pretty much already done this next problem out loud already. It says, in the picture from problem 23, this picture, let measure of angle 6 equal 80 degrees. Do that. Put 80 degrees in the picture. They give you information. You put it in the picture. Sound cool? Measure of angle 7 equals how much? Is it 80 degrees or is it 100 degrees? 100 degrees. Put it in the answer blank also. It goes in the picture, it goes in the answer blank. Justification. How did we know that this was 100 degrees after they gave us the fact that that was 80 degrees? How did we know that? Linear pair theorem. You got to ask yourself, well, what kind of angles were 6 and 7? Weren't those the two that we dealt with? We started with 6, then we talked about 7. Fill out the rest of these blanks with PAL. We've already done them out loud. See how well you can do with them. Justify everything you do. So we should have had those justified. We just did them out loud. They're all, this is 80 by linear pair theorem. That's 100 by linear pair theorem. Now, notice your vertical angles. Aren't these guys vertical angles? What do you notice about them? They're both 80 degrees, right? Here's another set of vertical angles. What do you notice about them? So what's equal about them? The measure of those bad boys. So let's see if we can figure out the vertical angle theorem without me showing to you. I'll start it out for you. Just let's talk it out loud. If two angles are vertical angles, then what do you think? What do you know about vertical angles so far? They have equal measures, right? Boom. We can also say that that's called congruent. If two angles are vertical angles, then they are congruent. If you put equal measure, that's good. If you put congruent, that's good. Remember, measures are equal and angles are congruent. Same concept. Means the same thing. If two angles are vertical angles, then they are congruent. Let's learn to justify now. We have two theorems to choose from. Everything else will fall under the category of a definition so far. Number 25. Given. Can you sum up what they gave us into two juicy words? What did they give us? Vertical angles. Right? Isn't that the juiciest thing that they gave us? So I ask myself, do I have any theorems about vertical angles? That's the first thing I want to know. Do I have any theorems? I sure as heck do. I got a vertical angle theorem. So if 3 and 4 are vertical angles and I know the measure of angle 3, what should the measure of angle 4 be? The exact same stinking thing, right? 76 degrees. Why? Vertical angle theorem. So vertical, you will not abbreviate that word because we don't know how to spell it right. Angle, check this out. Doesn't that mean angle right there? Theorem. T-H-M. Theorem. Vertical angle theorem. Sound good? Over to 26. Straight over. What's the two juiciest words they give you? They again give us vertical angles. Right? Angle 2 are those guys. If the measure of angle 2 is 134, what's the measure of angle 1 going to be? 134 degrees. Reason? Vertical angle theorem. Baby. Will every single one of these turn out to be vertical angle theorem? No, we got to go one problem at a time. 27. Given the picture. Cool. So we got to move over to the picture. All right. Here's the picture. It's an X! Oh my God! Is it always going to be vertical angles because it's an X? Are there linear pairs in that picture? Yes. Aren't angle 1 and 2 a linear pair? Aren't angle 2 and 3 a linear pair? 3 and 4 are a linear pair? And 4 and 1 are a linear pair? Right? So just because it's an X doesn't mean it's going to be vertical angles. Here we go. It says in the picture at the right, measure of angle 1 is 62 degrees. put it in the picture. If they give you a picture and they give you information, put it in the picture. Isn't that how you do that? 62 degrees. Cool in the game? Then, what are they talking about? Oh, they want me to find the measure of angle 2, which is right here. Correct? So it's time to talk to yourself. I have 1. They want me to find 2. I must ask myself, self, what kind of angles are angle 1 and angle 2? You only have 2 choices when I ask you what kind of angles are they to this point. You got linear pair or vertical angles. What kind of angles are 1 and 2? Linear pair. Cool with that? Don't they form a line? See this angle 1 and that angle 2 right there. Don't they touch each other and form a line out of the process of that? If this one is 62 degrees, how much should the measure of angle 2 be, my friends? Put it in a picture. 130, no, my bad. 118 degrees. Sound okay? Put it in the blank and justify it. Why is that 118 degrees? Help me. What is it? Bingo. It's all about what kind of angles they were. It was a linear pair, so the linear pair theorem says they have to be supplementary. Sound cool? Now, same picture, right? Information change. So, oh no, I didn't give you more than 1 picture. It's time to go. Peace out, Girl Scout. That information is gone. Now we must start over. I hate having to erase information. I try to give you a different picture each time, but if they use the same picture but they change the information, you probably better erase it. Okay? Let's do this now. In the picture at the right, measure of angle 2 is 143 degrees. So, 143 degrees. What would we do next? All I did was take info, put it in the picture. What would I do next? Well, I'd probably look at what they want me to do, right? Angle 4. Find it in the picture. There you are. And then talk to myself. I've got angle 2's measure. They want angle 4's measure. Do I know if they have a special relationship? What kind of angles are 2 and 4? So, how much should angle 4 measure? 143 degrees. Reason? Vertical angle theorem. So simple. Go through a process. Talk to yourself. Read information. Put it in a picture. Talk. What kind of angles are these? What kind of angles are those? Do I know anything special about it? Cool. Simple one. Now, let's step it up a notch. Measure of angle 1 right here. Well, they didn't really give you a bunch of stuff, but the picture, measure of angle 1, how much? Put it in the picture, put it in the blank, and justify it. It is 117 degrees. But how come? Because you got to ask yourself from the beginning, what kind of angles were the 1 and the 117? Weren't they vertical angles? Because they're right across from each other in the x. So vertical angle theorem. Says so. Nice. Next one. Then we find the measure of angle 2. I have a 40-degree angle. So I talk to myself and I say, what kind of angles are those? Are they vertical angles or are they linear pair? They're right next to each other, right? Don't they form a linear pair out of this bad boy? So if this one's 40, how much is that one got to be? Put it in the picture, put it in the blank, and justify. Last one's all you and pal, 31. Get her done. Pretty simple concept right there. Now, can you take the idea and learn to deal with it? Find the value of each variable and justify your answer. You see them instructions? It says justify your answer also. Hey, see these? Here's 120. Here's 2x minus 10. What kind of vertical angles is correct? They're the same, a.k.a. equal, right? To solve for x. Yeah, 120. What do you know about it? And you don't need the parentheses around the 2x minus 10. This is just trying to say it's all in degrees, right? You know, so the parentheses, there's nothing outside it. You're not distributing or anything like that. It's just 2x minus 10. So solve for. First move, add 10 to both sides. Nice. Finally, divide by 2. X equals 65. Is it degrees? x is not an angle measure. It's just an x, right? X is 65. If we was to substitute it back in, you'd get all of that, and then the degrees would be there. But we need to justify our answer. We're going to do it right next to this. Where did that equation come from? How come that? What kind of angles were these? So where did this equation come from? The vertical angle theorem says we can do that. Right next to our equation that we write. Goody goody gumdrops. Next guy. Here's an expression. There's an expression. What kind of angles are they? Which pair is correct? Slow down. Are they equal to each other? No. What do you know about linear pairs? These do what? They don't equal 180. They add together to equal 180. So don't we need to take this one and add it to that one? And let's skip a step. Can we combine like terms in our brain? Don't you add x's with x's and constants with constants? You got 2x and 4x. How much total x is that? 6x plus the 108. Is that it? 6x plus 108, that's it? It's got to equal 180. Shouldn't those two together add up to equal 180? Took a step and combined the like terms right away, and then wrote an equation. Now let's solve for x. That is a 108 right there, but it's got to equal 180. Right? Okay? Then subtract over, you get a 72. And then 76. What's that? 12. We needed to justify our answer, though. We need to go justify where this equation came from. Was it the linear pair theorem that let us set that up? Linear pair theorem. Let us set that equation up. Sound awesome? No. Okay. There's 3 different expressions. See these two? They don't play nice. They don't. They're a linear pair, right? They don't. One has an x with it, the other has a y with it. And y. All the time. So, do you see more than one expression with the same variable in it? What about these two? Don't they both have x's in them? Equation with those. What kind of angles are they? So, do I add them together and set it equal to 180? Or do I set them equal to each other? Vertical angles are equal to each other. So, let's do that. 2x plus 25 equals 3x minus 10. I'm a fan of taking the smaller amount of x's to the other side. I want to take these 2 x's over there. What's 3x minus 2x? 1x. I don't try to do 2 things at once. I'm not that skilled yet. Actually, I am, but you I just subtracted 2x from both sides. Next move, add 10 to both sides. Right? And x equals 35. Let's try this. It was vertical angle theorem. But we're not done. Because didn't it say find the value of each variable? How in the world can I find y? I don't have anything to set it equal to right here. And I can't set 2y equal to 2y. That turns out to be a true statement. Don't plug it in, but do what? Substitute 35 in for x, right? Let's do that. 2 times 35. Add 25 to it. What do you get? 95 degrees. Put it in your picture. Anybody know 5 degrees? What this one should turn out to be? They should have to 180, but this is 95. How much has that got to be? 85 degrees, right? You could say 2y plus 95 equals 180. First move would be subtract 95 from both sides, and you get 2y equals 85, right? If this is a number, and you know it, figure out what that number is. By way of the linear pair theorem, and say 2y equals 85, y equals 85 over 2, which doesn't make much sense to me. This wasn't an algebra problem. It's more of a geometry problem, correct? So how about 42.5 for y? Stokely do with where that came from. Equals 85, right? Yes? Are we okay with that? I moved really fast. Where did 85 come from? How did we do it? What justifies our reason where the 85 came from? Linear pair theorem said so, that these two should add together to be 180. Okay with that? All right. Is that it?